right. Welcome to Friday paper video number 20. So this is Friday paper 20. And this one is due January 15th. Okay, so in this video, I'm going to do problems 2, 3, 5, 7, 8, 10, 12, and 13. This is a tough Friday paper, so I'm going to help you out with quite a lot. All right, so the first problem that I'm going to do is number 2. So it says, between which two whole numbers is, and this is supposed to be the square root of 18. Okay, so square root means if I take, for instance, the square root of 16, that means what number times itself is 16? 4, right? It's a perfect square, 4 by 4. And so the next perfect square that's bigger than 18 is 25. And so the square root of 16 is 4, and the square root of 25 is 5. So those are the whole numbers that the square root of 18 is between. So it's going to be a decimal that never repeats. So that makes, when you have a non-perfect square root, it makes it irrational. That just came up on ClearSight recently. So, all right, let's do number 3. Is the opposite, or is negative 5 squared equal to negative 5 squared? So you can see where this is similar, but I'm going to show you why it's a little bit different. So did you notice how when I said this out loud, whenever you see a negative like that in front of a number, you can also technically say it's the opposite. Okay, so it's the opposite of 5 squared. So when you think about that, it's also kind of like saying negative 1 times 5 squared, right? Because when you multiply by a negative 1, that gives you the opposite of that number. So if you look at the order of operations here, you know PEMDAS, parentheses, exponents. So exponents come before multiplying. So we're going to do this exponent, and we get 25 times negative 1. So what's the opposite of 25? It is negative 25, right? So this one, if I evaluate it, it becomes negative 25. This is different. This is saying, let's take this integer, negative 5, and let's square it. So this means negative 5 times negative 5, and that's going to be a positive 25. So the answer here is no, they're not equal, because the opposite of 5 squared is negative 25, and negative 5 squared is 25. So the answer here is D. It's time to go home, so we're going to pause this video. Okay, I'm back. Are we unpaused, hopefully? I think I'm rolling. Hopefully you can see me. All right, so let's go back here to our paper. And does it tell me somewhere that it's recording? I really hope so, because I don't want to say all this and then not have it record. Let's just see if we can find somewhere. Just to make sure, this little button, click it. Your desktop is being recorded. Amen. Good. Okay, so finish number 3. Let's do number 5. So it says mark whether each statement is true or false. All right, so this is kind of written because it's one of those iLearnish, ClearSight-ish type questions that they like to give. So this again says the square root of 32, the square root of 9, and the square root of 12. So as a reminder, square root means we want to find some number times itself that equals that number. Well, if I tried to make a square, like I'm trying to construct a square over here, and the area is 32, I really can't do it. because there's no number times itself that equals 32. But is there anything close? So I'm thinking, here's what I'm thinking. I could make a square out of the number 36, because that would be 6 by 6, right? Because then that makes the number 36 a perfect square. So the square root of 32 is between the square root of 36 and what's, so if this is 6 squared, what's 5 squared? That would be 25, right? Now, we got to get a little more detail. So I'm going to zoom in here just a second. So which one of these is it closer to? 25 or 36? 32, 33, 34, 35, 36. That's only 4 away, right? And it's further from 25. So it's closer to this one. So how far is it from 25 to 36? 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So it's 11, like it's 11 steps from here to here. And so halfway would be 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Yeah, 31. So 31 would be right about 5.5, right? 5.5 would be about 31, 5.5. So why don't we go up like one more decimal point? So I'm going to say it's about 5.6, okay? But either way, is 5.6 less than 5.1? Is 5 6/10 less than 5 1/10? No, right? Even if I just got this close, right? I know it's not less than. So this is false. This is false. You can put a check mark or a X. I don't care. So square root of 9 is 3. Is 3 less than 3 1/100? Yes, it is. It is, but it is less than 3 100. So we're going to say that's true. The square root of 12, is it a perfect square? I have a square with an area of 12. Is that possible? No. I could do 4 times 3. That'd be a rectangle though, right? So what's the closest perfect square? 16. 4 by 4, right? So underneath it is the square root of 9, which is 3 squared. Here I have the square root of 12, and here I have the square root of 16, which is 4, because 4 times 4 is 16, 3 times 3 is 9. So the square root of 12 is some decimal between 3 and 4. And if you have a square root that's not a perfect square, it's going to be it's going to be a non-terminating decimal, meaning it's and it's not going to actually repeat. So it's not rational. So this is irrational, but this one is rational because it simplifies to be 3, and 3 can be written as a ratio of 3 to 1, 3 over 1, right? Fraction. Okay, so let's do our thing again. Is this going to be closer to 9 or closer to 16? 9, 10, 11, 12. That's only 3 away. And then 13, 14, 15, 16 is 4 away. So it's closer to this one. So it's 3 point something. I don't know. Maybe 3.4 or something, right? Close to that. So it's about 3 4/10. Is that greater than 4? No, it's less than 4. 3.4 is not greater than 4. So this is false. Okay? All right. So I know I said I wasn't doing these problems here, number 6, but we'll cover them in class. These are your exponent rules. And just so that you're ready maybe for class, I'm just going to write those rules. So if I have a base of x and a base of x, a common base, those exponents, the shortcut is to just add them together, right? I'm multiplying here these numbers raised to an exponent, base raised to an exponent. If they're the same base, if these are the same, I can just add the exponents. okay? If I have a base raised to an exponent, and then that term is raised to another exponent, the trick here, or the shortcut, or the rule, however you want to say that, the rule is that I'm going to multiply those two exponents, okay? If I'm dividing, so I have this monomial, remember that word monomial? This monomial, base raised to an exponent divided by the same base. It has to be the same base. That's the big number, right? The big number. Raised to this base. The rule says I'm going to subtract the bases, right? But I have to do it in the order that it's given to me. And in a problem like this one, for instance, this is the numerator, okay? This is the denominator, and I have to do 5 minus 1, okay? All right, so it looks like those are the only rules that we need for that. You'll remember this rule, any monomial raised to the 0 power is 1. Okay, let's do number 7. Looks like my head is in the way. Let's move my head up here. All right, so 7 says multiply. Put your answer in scientific notation. Okay, scientific notation looks like this. 6 times 10 to the third, right? You have to have some number here between 1 and 10. This is between 1 and 10. So this is in scientific notation. Times a power of 10. This is what makes this scientific notation. Some number n that is greater than 1 but less than 10. Okay, that's what it has to be. Now, what we're going to do is we're going to treat this like a monomial of sorts, and we're going to go ahead and we're going to multiply these as if they were like coefficients, kind of. We've done that in the past. They're not really, but we're going to multiply 9.91 times 6. 6 times 9 is 54, 55, 56, 57, 58, 59. And I move my decimal over twice. So I have 59 and 46 hundredths times 10, that's what I'm doing, to the 3 plus 0 to the third. I took advantage of the rule that we talked about up here where I can add those exponents. But now hold the phone. It says, put your answer in scientific notation. This isn't actually scientific notation, right? Because 59 is definitely bigger than 10. Remember, the rule says this first number here has to be between 1 and 10. So what I'm going to have to do is I'm going to go left with that decimal, and that means I need to then raise the roof on this exponent to make it bigger. So like if I'm making this number smaller, right, I'm making it 10 times smaller, I need to multiply by a greater power of 10 to make it equal. So my answer here is going to be 5 and 946 thousandths times 10 to the fourth power. Okay, let's do number 8. Okay, number 8 says, number 8, there it is. Which of the following is the linear equation of a line passing through these points? Negative 1, 4 and 1, 2, right? And so if you're a visual person and you need to kind of wrap your mind around this, you can always graph things, right? Negative 1, 1, 2, 3, 4. It's going to be there. 1, 2, 1, 2. Okay. And if it's linear, it makes a line and it goes through those points. So I kind of have a visual aid. So how do I find, so I'm like trying to find the equation of this line because I want to know which of the following is the linear equation of this line, right? So whenever I need to find that out, by the way, linear just means it makes a line, right? See the word line in it. I got to have two things. Y equals mx plus b. I need the slope, and I need the y-intercept. Okay, now looking at this, I know it's not a perfect drawing, but Can you kind of see what the y-intercept might be? Well, you can kind of rule some things out. Does this line look like it crosses at -3? In other words, this is y equals mx plus b. The y-intercept here is -3. That'd be down here, wouldn't it? No, it's not happening. Now, just looking at this one, does it look like it could be a +2? You know, that one's kind of close because my picture might just be off. So maybe, right? Could it be a 4? I don't know. How about, could it be a 3? 1, 2, 3, maybe. Maybe my picture's just off. We'll even leave this one in contention just in case. But then here's what you're going to do. You're going to say, wait a minute. This slope, is it positive or is it negative? Right? This line is negative. It's a negative. It goes down from left to right. So that means my slope, or my m, has to be a negative number. Is this a negative? No. So I'm definitely marking that one out. Is this a negative? No. That's a +2, so I'm marking that out. And for that matter, is that even an equation? It doesn't even have an equal sign. I should have marked that out from the very beginning, right? Let's try this one. Yeah, negative, so it's in contention, and negative, that's in contention. So my sketch helps me to rule some things out, but I still have to get a little more detail. So I've got to go back in here, and I'm going to use my slope formula. And remember, what that means is I'm going to subtract my y's, so change in y over change in x, right? And change always means subtract. So my y values are 2 and 4. I always like to start here, furthest to the right. So I rewrite that as 2 minus 4. And then I come to my x's. I come back to this guy, 1 minus -1, right? So minus and negative is really adding, isn't it? Looks like a face. I, nose. So this is really 1 plus 1, which is 2. So this equals 2 on the bottom, new denominator. 2 minus 4 is -2. What's -2 over 2 simplified? That's the same as -2 divided by 2, or it's saying 2 times what gives me a -2. That would be a -1. So this is the slope between these 2 points. So now I know for sure what the slope is. This slope says -2. That's not right. This slope says -1. So this is my answer. Now, there's a little bit more we could have done to get it narrowed down, but I think we've done enough. So let's go ahead and move on to number 10. This is something that you haven't seen yet, okay? And it's talking about a system of linear equations. And basically what we're saying here is that we have some number y. Y is equal to this whole thing, right? Y is equal to this expression, and y is equal to this expression. Oh, is that the transitive property? Mrs. Golding's brain just farted. Let's look it up. Transitive property. See if my brain fart is working. Images. If A equals B and C equals B, then A equals C. Ooh, yeah. Transitive. I know if somebody's listening to me, they're like, Mrs. Golding, why don't you remember these? Properties of equality. Properties of equality. Reflexive. No. Symmetric. If x equals y, then y equals x. Not exactly. That's not what we're talking about. If x equals y, no. Addition, subtraction, multiplication. I guess you'd really say it's the transitive property. Yeah. I think that's right. Is that what I said from the beginning? I hope so. Okay, so if y is equal to this, and y is equal to this, that means these things have to be equal to each other, right? If A equals B and B equals C, then C has to be equal to A. That's really confusing. So in other words, all I can do is I can take these y's out. It's like, let's get rid of them. So we say this number, not this number, this expression has to really be equal to this expression. Because if y equals that and that, then they have to be equal to each other, right? So the cool thing about it is then I can just solve it like an equation. Because I just have one variable, right? So I'm just going to solve. So let's start with our variables. And I get 1 is equal to 987 x plus 8. And then I'm going to subtract 8 from both sides. 7x is equal to negative 7 divided by 7, x equals negative 1. Now, notice if you look over here, there's an ordered pair. Wait a minute. I only have one part of that ordered pair, right? So I have the x value of this ordered pair. And so I need to find the y value. So what I'm going to do is I'm going to plug this into one of them. I'm just going to choose the top one. Y equals 2x plus 1. Y equals 2 times, we just decided x is equal to negative 1. So let's just continue. 2 times negative 1 is negative 2 plus 1. So y equals negative 1. So my ordered pair, which is the solution to this system of equations, is negative 1, negative 1. Now here's the really cool part. The solution to a system is where these two lines actually cross. So I'm going to go into Desmos and show you really quick. You're like, Mrs. Golding, why are you doing all this? Well, because it's important. Desmos.com. And you guys, I hope you're using Desmos a lot. It's linked in my Canvas page. And I do that for a reason, because it's such a great resource. Not just the calculator. This is Desmos.com. Now here, look, you can put in any linear equation. Y equals 2x plus 1. Okay, it graphed it for me, right? And I'm going to put in the next one. Y equals 9x plus 8. Oh, now look at this. So the blue line is this equation, is the line that's made by this equation. This equation is the equation of the blue line. That's probably the best way to say it. This is the equation of the red line. So if I'm looking here, the solution is finding the point where they intersect, where both lines are true. And so look, if I put my little pointer right here, it gives me that. Do you see? Negative 1, negative 1. That's what we found algebraically using algebra, right? But we can also find it graphically using tools like Desmos or graphing it on our own. So I love Desmos. Okay, let's go to number 12. So technically, I just showed you a tool you could use to kind of get an idea. If you're totally lost on something like this, and you're like, my brain is not even functioning in this, put it in Desmos and see what it looks like, and then try to work backwards. Like how'd they even get that, right? So what you're going to look for here, this is y equals mx plus b, right? And the m is 2/3 and the b is negative 4. So this is where we always begin. I like to begin, right? That's the b. The b is the y-intercept, where it crosses the y-axis. And remember, the y-axis is the one that goes up and down. So it intercepts the y-axis at negative 4. So I'm at the origin, which is 0, 0. Negatives go down. 1, 2, 3, 4. I'm going to put a point there. That's my y-intercept from this line, this equation of this line. Now I have to find the slope, 2/3. Remember, slope is rise, so m is rise over run. So I can start here where I begin. That's the b, right? rise 2. Isn't that what that says? 2 over 3. Rise 2. 1, 2. Run 1, 2, 3. Okay? Ooh, I don't have a straight edge. Let me go get one. I'm running. I'm running. I'm running. Here it comes. I'm coming back. I'm running back. Straight edge. If you need one of these, ask me. I have tons of them. They were in your packet if you got a packet during remote learning. Notice, I like to draw that line all the way across the coordinate plane because it really goes on forever and I put those lines. So there we go. I graphed that linear function. A function. Okay. Last one is 13. I feel like this video is forever long. I'm so sorry. So 13, it looks like my head's in the way again. Let's move you down here. Okay. Write the equation in slope-intercept form, y equals mx plus b, for the line that passes through the given point and has the given slope. So I'm given a point and I'm given a slope, right? So one thing you could do, you could use Desmos. You could find that point. You could use that slope and kind of look and see where it would be on a graph. You could graph it on a piece of graph paper. We're going to use algebra, okay? And we're going to use this method. So we're going to use slope-intercept form, and we're going to solve for what we need to know. Because when we are writing anything in a slope-intercept form, a linear equation, we need the slope and we need the y-intercept, right? So slope, do I know it? Yes. Y-intercept, do I know it? I got to find it. So we're going to use what we have. I have a y value. Yes, I do. I'm going to label them as a matter of fact. I have an x value and a y value. This line goes through those points so I can use them. So and what it's actually saying is -1 is equal to -2 times 4. See, that's my x value, plus b. Okay. So what it's saying is when x equals 4, y equals -1, when I do this stuff to it. Okay, so this is like that function is what's happening to it. So I'm going to go here and I'm going to solve. -1 is equal to -2 times 4 is -8 plus b. Let's just get b by itself. Let's isolate the y-intercept. Okay, -1 plus 8. That's a positive 7, I think, right? And then equals b. So we solve for b. Is that my answer? Is that what I was trying to get? No, but it's a part of it, right? So now I have the b and I have the m. So that's enough for me to write the equation, right? So my equation is y equals mx plus b. And it's a positive 7, so it's plus 7. So you're going to follow that same process as you do number 14 and as you do number 15, okay? So solve for b. Set it up exactly the same way. All right, so we're going to work hard on this rest of this paper. Hopefully this will give you a good start. And remember, you're important and the world needs you. Have a great day.